Hello everyone, I'm Dan Cairo. Today I would like to demonstrate the execution program from the Lab2 exercise, which is arithmetic equations and operations. So let us start with the question 1. From this question 1, you can see it already gives us the program, and we need to observe the value of the register when I execute the program line by line. So let us build the solution first. Okay, it successfully, so we debug. Start debugging. I use the F10 to debug. Okay, so in this question, we need to observe the variable value. So e and add items variable 2. Okay, and register. AX register and BX register, which we only observe the last 4 bits, AX and BX, and other register we no need to observe. Okay, so I execute. Move AX. So AX value now will change to 0001 because variable 1 is hold the value 1. So AX last 4 bit will change to 0001. So I press the 10. Yes, it's true. And move BX variable 2, so BX will be 0009. Yes, and exchange AX BX. So AX value will be 0009 and BX value will be 0001 after I press the F10 button. Okay, so it's true. And move variable 1 with the value AX. So we observe the variable 1, now it's 0001. So after I press the F10, it will become 0009, this line. Okay, so okay, yes, it's true. And variable 2 will be 0001 after I press the F10. Okay, now I will call the dump register. As you can see, 0009 and 0001 is the final value of the register. And variable 1, variable 2 will be, variable 1 will be 0009, variable 2 will be 0001. So we will continue the question 2. Okay, in this question, you can see it already gives us an arithmetic expression. R variable equal, as you can see, is here, and it's already gives us the code. So in this question, we need to check this code is related to the expression or not. So in first, you can see in data section, it already gives us R variable, S variable, Y variable, Z variable, which hold the data type D double. Okay, S variable hold the value 26, Y variable hold the value 30, Z variable 40, R variable is nothing. So I will build the solution. Debug, F10 debug. Okay. F10. So move the X variable value into register EAX. So EAX will become 000001A. And negation EAX is mean change the EAX to 2 complement mode. So it will become FFFFF E something FFFE6. Okay. And move the Y variable into register EBX. So EBX will become 000001E. Yes, it's true. And subtract the EBX with Z variable value and hold the and store the value in EBX. Okay, and add the EBX value into EAX and increment EAX. It means EAX value will become plus 1. It will become FFFFDD. So after I check, press yes, it's true. It's become FFFDD and move the EAX value into R variable. Press. So R variable will become FFFFD. Yes, it's true. So it's all this one is question 2. So we'll come to the question 3. In this question 3, it's already give us an arithmetic expression, and the code we need to check the code is related to the expression or not. In this expression is include the multiply, so it's quite interesting. In data section, you can see variable 1, 2, 3, 4, double word data type, and variable 1 hold the value 5, variable 2 hold the value 10, variable 3 hold the value 20, and variable 4 nothing. So we'll build the solution. Debug. Oh shit! I pressed the debug. I need to press F10. Okay. F10. So if I press the F10 again, it will move the variable 1 value into the register EAX. So EAX will hold the value 0.00005, and multiply variable 2 is mean multiply EAX with the variable 2, so it's mean 5 hexadecimal multiply a hexadecimal value, so it will become 32 in hexadecimal, and add EAX with the variable 3 value, so EAX value will be changed to 46 in hexadecimal, and decrement EAX is mean that, as you can see, the expression will -1, decrement EAX is a result -1. Okay, so I press, it will become 45 in EAX register. This one, focus on this. Yes, 45. So is the question 3. Now we will continue with the question 4. In this question, it already gives us the arithmetic expression, as you can see here, and the following code. So in this question, we will need to check the code is related to the expression or not. So in data section, we will see the 3 variable 1, variable 2, and variable 4, which is word data type, and is hold the value 40, 10, and nothing. So we build a solution first, and we debug F10. So in the expression, we need to variable 1 multiply by 5. So first we need to move the variable 1 into the register AX. So AX, and AX now is 002A, and move the 5 into register BX. So BX now is 0005, and multiply BX will automatic multiply BX with the AX. So AX now is C00CX, and we clear the BX and move the BX with the variable 2. So BX now is the hold the variable 2 value, which is 000A, same with the EBX. And we subtract BX with the value 3. And in this line, we will divide the AX with BX. So so AX will change to 001C, and DX will hold the remainder 0004. And we will put the result into the variable 4 using the value of AX. And this will the result for the arithmetic expression. So it's all the question 4. So we come to the question 5. In this question, we need to write a full program to execute the code snippet. So it gives us the code section. We need to write the full program for this. So we build the solution first to see the program is successfully executed or not. Yes, it's successfully built, and we debug. In this case, we don't use the watch window because it's not contain any variable. We just focus on register only. First, we clear the DX. So we move 0 value to the register DX. So you can see DX now is hold the value 0000, and we move AX with the value 1000 hexa. Yes, now it's changed, and we move CX with the value 25 hash CX. As you can see, it's changed, and we will multiply CX. It automatically multiply CX with the AX. So the result will storing the result in DX AX. The most significant 4 bit will store in DX, and least significantly will store in AX. So it will change to, we can calculate it. Calculator. Hexa now is 1000 AX, and multiply 25. So after I press the F10, the AX will change to 5000, and DX will be 0002. Yes, it's true. So that's all for the question 5. And now we come to the last question for this lab 2. So in this question, we also need to write the full program to execute the code snippet. So we will try to build the solution to test the code we write is true or not. Build successfully, and we will debug. And okay, so in this code, we will try to test the divide operation. So first, we clear the dx value is move 0 into register dx, and we move the value 803 hexa into the register ax, and we move the 10 hexa into the register bl. So divide part, we only use the we no need to use the dx combined with ax to do the operation divide, because we just divide with the value bl. So the AL will hold the value quotient, and AH will hold the value for the remainder result. So we can try to calculate the answer. So hexa 803, the decimal value is 2051, and hexa value for bx10 is decimal value is 16. So 2051 divided by 16 is 128, and we calculate the remainder first. 128 plus minus, so remainder in hexa in decimal is 3, so we convert to hexa is also is 0003, and 03 only, because it's only include 2 bit, and the quotient will be hexa is into quotient will be 80. So the AL answer will be 80, and the AH answer will be 303. So we test F10, execute the line. Oh, yeah, answer is 03 x 0, so it's true. So that's all for the question 6, which is last question for this lab. Thank you.